Okay, so this question involves constant forces. When you read the question, all the forces they're talking about are constant. If that's the case, constant forces means we've got a constant acceleration, okay? And we're told the acceleration is 0.8, okay? So it's shifting this way. If the acceleration is constant, we can use SUVAT, we can use the equations of motion here, okay? But before then, we need to consider all the forces that are acting here on the car and the caravan. We'll be told there's a resistant force acting on the car, okay, of magnitude 200 newtons, and there's a resistant force acting on the caravan of magnitude 300 newtons. Of course, then there's a driving force, okay, there is a driving force from the car, from the engine of the car, pushing it forwards, and then we're told then that this is of magnitude p newtons. We don't know what p is yet. Now, when you look at this here, you can see now how the car would be moving forwards, yeah, because of this driving force here, despite the resistance. This is obviously going to be greater. But when you look at the forces I've got here now, you'd be wondering, how on earth is that caravan moving? Because it's just got the resistance here. But of course, that's not the end of the story, isn't it? There's a connection here with the tow bar, okay? So the tow bar, which is connecting the car and the caravan, okay, is then pulling that caravan along, all right? So it's the tension in that tow bar here, which is pulling that caravan, okay? There's a strength in that tow bar, which is pulling that caravan along. But we need to think about the tension force in that tow bar, because not only is it pulling that caravan along here, okay, so having that forward force, it's also having an effect on the car as well. So that tow bar is not just having an effect on the caravan, it's having an effect on the car, and it's actually pulling back on the car, isn't it? You know, if you're ever towing something and you're in the front car, you feel that tug from behind, okay, because you're pulling something and it affects your movement forward. So that tow bar has an effect not just on the caravan in terms of pulling it forward, it also has an effect on that car in terms of pulling it back. So we need to have the tension acting that way as well, okay, to show the effect that it has not just on the caravan but also on the car as well, and then it's pulling it back. So we've got all our forces in the horizontal direction here labelled. Now, because this is to do with forces, to work out P, I'm going to use Newton's second law, okay? So using Newton's second law, now remember, we always think about then the direction of motion, okay? It's the direction it's going in. So the resultant force is equal to mass times acceleration. So the resultant force, well, we've got P, the engine force, okay? Then we've got, take away then the resistances on that car, which is T, and then take away 200, okay? So the tension in that tow bar, okay, is holding the car back, and the resistance. And then we've got this T here. Well, then we're going to add that T, aren't we, on, because that T is going in the positive direction, okay, in the direction of motion. And then we're going to take away the 300, the resistance force on the caravan. That equals then to the mass times acceleration. Now, the mass is the overall combined mass of both car and caravan, right? So the car was 1200, the caravan was 1000, so that'll be 2200 times the acceleration, which is 0.8. Now, what we find then is that the t's will cancel, okay, which is quite nice. So you get P then, take away 500 equals to then 2200 times 0.8. So P then will equal to 2260 newtons. Okay, so that's the driving force of that car there. Part 2 then, it says find the magnitude of the force in the tow bar that connects the car to the caravan. So we actually now want to find out what this tension is in the tow bar. Okay, and what we can do then is just focus on one of these vehicles, okay? In particular, I focus on the caravan because there's less forces acting on this caravan, okay? We could have actually got that wrong as well. So if we focus on the car and we got that wrong in the first part, then we'd end up getting the tension wrong. So let's just focus here on the caravan, okay? So if we sort of zoom in on that there, forces on the caravan using Newton's second law again, we've got the tension pulling it forwards, take away the resistance, which is 300. Okay, so that's the resultant force. Tension pulling forward, take away the 300, that will equal to then the mass, which is, now the mass of the caravan this time, just the caravan, which is 1000, times the acceleration, which is 0.8. So that will be then 800 then plus the 300, so that tension will equal to 1100 newtons. Okay, part B then, part 1, it says find the time that it takes for the speed of the car and the caravan to increase from 7 to 15. Now remember, because the acceleration is constant, 0.8, we can use suvat. Okay, so we want to find the time it takes to get from 7 to 15, so using V equals U plus AT. So V is 15, U is 7, 0.8 for A, and then the time, so we can work that out then. If we take that 7 over, take away, so we get time then to equal to 10 seconds. It says then find the distance that they travel in this time. So distance, well, we can use the formula involving time. So which one should we use? We've got S equals UT plus half AT squared. That would make sense. That would involve time, wouldn't it? We could use V squared equals U squared plus 2AS. I think that would be a more sensible one because it's not involving the time, isn't it? We could have made a mistake with that time. So if we use that one, well, V squared, 15 squared, U squared would be 7 squared, 2 times 0.8 times S. So if we work that out, 225 there, 7 squared is 49, 1.6 S. So we get 176 equals 1.6 S. So that means then S will be 176 divided by 1.6. So we get 110 meters. Okay. Part C then, it says explain why the assumption that the resistance forces are constant is unrealistic. Well, when we think about the resistant forces, okay, 300, 200, being constant is unrealistic because as the car and caravan get faster, they're likely to occur greater resistances. Okay, so you can say, look, as speed increases, resistances are likely to increase due to air resistance mainly. Okay. Because the faster you go, the greater air resistance you're going to encounter.